Let's learn together. I'm your host, George. In this video tutorial, we are going to learn how to take an input from a user keyboard and print it out to the screen. For example, we're going to prompt the user for a name. Maybe something like, what is your name? Question mark, right? So the user will enter a name, for example, Geore, and we want to print that to the screen along with something like, hello, George, the name that was entered, followed by an exclamation mark, and perhaps something like, how are you today? Question mark. So in order to get keyboard input from a user, you need to create a buffer. A buffer is a block of memory where all the characters that are entered by the user are stored. And to create a buffer, you need two parameters for it. The first one is to limit the number of characters a user can input. And the second one is the actual number of bytes that you want to reserve in this buffer. For example, I'll create a variable called buff for buffer. I'll say define byte. Let's assume we want 10 characters. Limit this, and I'll put a comma after that. And this will give me a total of 9. It's usually whatever the number you input minus 1. So by putting in 10, this will allow 9 characters to be typed in by the user. And the second parameter is how many bytes you want to save or store for this buffer. I'm going to say another 10 bytes, and I'll say dupe parentheses open quote $, close quote, and close parentheses. So let's prompt the user for input by loading this variable buff into dx register. I'll say load effective address into dx of our variable buff, and then we'll move into a edge service 10 and then call interrupt21 edge. So let's click on emulate to see what's going on in memory, and I'll click on buffer. Now what you see is our variable is highlighted in yellow. As you can see, the first byte at address 102 is number 10 that we entered, the first 10 before the comma. And then after that there are 10 bytes duplicated of the $, just as I entered here, 10 dupe $. Now this first byte at address 103 is usually reserved for the number of characters that you're going to enter. So if I was to enter John, John, 4 characters, it would start at 104, 5, 6, and 7, and at 103 address, this will show number 4 for 4 characters entered. If I was to enter the name George, for example, 6 characters, it will start from 104, 5, 6, 7, 8, 9, and at 103 it will show number 6. The first one is the number of characters that we want to limit the user to type in, and if I say, which is 10 in this case, it allows 9 characters, so whatever the number is minus 1. If I had number 20 over here, this would be 20 minus 1, so it would allow only 19 characters to be typed in. Let's single click through this program and see what happens. I'm gonna load buffer into dx register and then move 10 into a edge and then call interrupt21, and we are prompted for input. So I'm going to type JOHN, name John, and I'll press enter. What happened? Let's click on buffer, and you'll see JOHN is started at address 103. As you can see, 103, I'm sorry, started at address 104. 103 has the number 4, reflecting the 4 characters that I entered. It does not count the character return that I pressed after the name John. And there are 4 bytes leftovers at the end. We reserved 10, we used 4, plus 1 was the character return, plus 1 is reserved, there's 4 left. And now we need to print the name that was inputted to the screen, right? So since we know our variable is 0 based, another word, it starts at 102, that's 0 based, 0, plus 1 would be 103, plus 2 would be 104. So the first 2 bytes are reserved, as I mentioned. It always, the characters that were inputted always start at plus 2. Since that's the case, we can create an equation similar to this. Let's call it input equal, I'll say buff plus 2. Now it would be easier for us to print that name by just simply loading into the X register input. This loads address 104 into DX. Then we can move into a H09 and input interrupt 21H to print that name. Let's run the program and see how that works out. Input, I'll say JOHN and press enter, and there you go, it prints the name right after what I typed in. No space and on the same line. So here's something else we can do. I can create another variable and I'll call it new line NL. I'm gonna say db13 carriage return 10 is new line, and then $sign. This will print a new line. What I could do over here is load effective address into DX of NL, move into a H09 interrupt 21H. This will move John to the next line. Let's run it again and see how that works out. Type JOHN, enter. There you go, it prints the name on the second line. Very well, since now we know how to take an input from a user and print it out to the screen, let's rewrite this program with all the prompts that I mentioned in the beginning of this video. I have prepared the prompts off camera for us, and we're gonna have 3 messages, obviously. The first one reads, "What's your name?" question mark, and there's a space after that, so that the user types the name after the space. The second message reads, "Hello," space again after that, so we can print the name after the space. And the third one has an exclamation mark right at the beginning, which will land right after the name, and then space, hurry the day, question mark, and ends the string with a $sign. I'm just going to copy that, and I'm going to paste that over here. Okay, let's also create a function, because we can do a lot of printing. I'm going to delete this and I'm going to delete that. We'll put this function, print function, over here. I'll say print string colon, and then move into a H09 interrupt 21H and return. So let's do some commenting here. So first we're going to do prompt print message 1, which is the prompt, and then after we print the message, the second block of instruction is take inputs, right? And the third line would be print new line, right? And I'm gonna say call print str string, right? And after we print the new line, we want to print the second message, right? So we're going to say load effective address into dx of msg2, and then call print string. And let me also comment this as print second message. And then once we print the second message, we want to print the inputs. Print input name. And once we do that, call print str. Once we've done that, then we're going to load the effective address of third message into dx, which will be message 3. I'm going to comment this print msg3, and we'll say call print str. I should do it. Let's give it a try. Other than load, I forgot to load this one. Load effective address into dx of msg1, and then call print string. Okay. Let me just tidy up a little bit here. I'll take that and put it up. Okay. Let's run the program, see how that works out. Run. Put the name in, John. Okay, so here's what happened. Let's do this. I'm going to close this and reload. And this time, I'm going to do single step. So first, we're going to load the first message and print it. First message is printed, return, then take buffer input. I'll type JOHN, enter, and print new line is next. So new line is printed, although we don't see anything, and then print message 2 next. It's called print string. So message 2 prints fine, and then print the input name. We loaded that, and then call print. So the name is printed too, just fine. And then the last message, what happens is it overwrites the previous prints that we did. So what's the problem? Let's analyze that. If you click on, I'm going to click on emulate and check the buffer. I have to run it first. I'll say JOHN, press enter. Okay, let's go to the buffer and look what's going on. Here's the culprit. The 13 character return after the name John, after we print that, is there. So what this does is brings the cursor back to the beginning of the line, so it overwrites the first 2 messages that we printed. So I can think of 2 ways of fixing this problem. One is to position the cursor where we want it to be to print the third message, which takes a lot of work. Or the other way would be just to override this character return over here at this address 108. We'll calculate where this character return position is, and then override it with a space, maybe 20h or $. So let's do that. So since our problem is at this point printing the name, we're gonna add some code instructions just before that to correct the problem. We're gonna override that carriage return right here. So let's figure out how to do that. I'll just click on emulate just to see the buffer again. And what we can see is, let me run it first. Okay. So if I click on the buffer again, we can see it starts at 102, The name starts at 104, which is the input that we created the equation. Input equal buff plus 2 points to this point, 104. The first 2 bytes I've reserved, so if we load 102, or I'm sorry, if we load 104 into BX register, then we load the value 4, which is in 103, buff plus 1, into AL. And then we add the two together, so 4 plus 104 will be 108, which points to that position where the carriage return is. Okay, so I hope you understand how this will work. So let's do that. I'm going to move into AL register, buff plus 1, which will give me 4 into AL. I'm gonna move into AH 0. I'm gonna 0 AH because there's a value in there and we need to add AX to BX later. And then I'll load effective address into BX of input. Now I'll add to BX AX and then move into what BX is pointing to, which is 108, the value of, or a $sign, an ASCII of a $sign. So let's see, I'll run this now again to this point, and we'll single step after that. JLHN. Okay, single step. So we put 4 into AL right there. Next, we 0 AH. Now we have 4 in AX. Now we load 104 into BX register, which is the input. 104. If we add them together, add AX to BX, gives me 108. Now I'll move $sign where BX is pointing to. So let me go to the buffer to see it first. 108 has carriage return, as you can see there. If I click next and go back to buffer, now 108 has a $sign. Now I can continue running this program to the end, and it works perfectly. Let's run it again. Emulate and run. JOHN. It works as expected. I'll run it again with a different name. I'll do GEORGE, 6 characters, and it still works. Cool. We've come to the end of another video. Please hit the like button, subscribe, comment, share, do whatever you can to help this channel with YouTube algorithm, and I hope to see you soon in the next video. Bye now.